Hello and welcome to Tech with Shaping Pixel. We are bringing you free certification course. This time we are bringing Google's Associate Cloud Engineer Certification Exam Crash Course. We have also included 206 real exam question answers with this crash course. Are you ready to evaluate your cloud skills? This learning path is designed to prepare you for Google's Associate Cloud Engineer Certification exam. But it's also perfect for anyone looking to enhance their cloud expertise. The exam tests your knowledge in 5 key areas: setting up a cloud environment, planning and configuration solutions, deploying and implementing those solutions, maintaining operations, and securing your environment with access policies. We start with an overview of Google Cloud Platform's main products and services. You will learn how to set up a development environment and install the Google Cloud Software Development Kit. Next, dive into configuring networks and creating virtual machines. Topics include autoscaling, load balancing, and network security. You will understand concepts like network address translation and configuring a cloud virtual private network. Then explore containers using Google Kubernetes Engine, App Engine, and Cloud Run. Learn to use identity and access management to keep your containers secure. Cloud offers powerful compute options. From virtual machines to Kubernetes engine, you can scale your application seamlessly. These services ensure high performance and flexibility for your workloads. Google Cloud provides robust storage solutions, whether you need object storage, file storage, or databases. Their offering like cloud storage and BigQuery cater to diverse data needs efficiently. Networking in Google Cloud is designed for speed and security. With virtual private cloud, load balancing, and cloud CDN, you can optimize traffic and ensure reliable connectivity across the globe. Google Cloud excels in AI and machine learning. Tools like TensorFlow, AutoML, and AI platform help you build, deploy, and scale intelligent applications with ease, leveraging Google's advanced AI capabilities. Security and operations are paramount in Google Cloud. Services like identity and access management, cloud security, command center, and operations suite ensure your infrastructure is secure and well managed. So stay connected, stay updated as Google continuously innovates. Google Cloud Platform or GCP is a public cloud vendor offering a collection of virtual non-demand services. It allows anyone to build, host, and deliver applications using the same hardware and software that powers Google services like Search, Gmail, and Google Docs. One of the main advantages of using GCP is access to Google's global network and vast experience in serving applications to billions of users. This means you can leverage their infrastructure without the hassle and cost of building and maintaining your own data centers. With GCP, resources are available on demand wherever and whenever you need them. This flexibility is complemented by a wide range of services, including artificial intelligence, machine learning, big data, Internet of Things, healthcare, and gaming. The options are almost endless. To make it easier to navigate, GCP services are divided into 5 main categories: compute, storage, networking, artificial intelligence and machine learning, and security and operations. In the coming up, we will explore each category in more detail, giving you a comprehensive understanding of GCP's offerings. Google Cloud Platform offers a variety of compute services to run your code. Whether you need virtual machines, containers, or serverless options, GCP has you covered. For virtual machines, Google's Compute Engine is the go-to service. It supports both Linux and Windows with predefined and custom machine types. Compute Engine is ideal for building from scratch or migrating existing infrastructure. Containers are lightweight alternatives to virtual machines. Google Kubernetes Engine or GKE simplifies deploying, maintaining, and scaling containerized applications. It includes features for logging, monitoring, and health management. For hybrid environments, Anthos allows you to run containers across multiple locations, including on-premises GCP and AWS. Anthos provides a unified command interface for seamless management. App Engine is Google's platform as a service offering. It lets you run web and mobile applications without managing the underlying infrastructure. Just upload your code and GCP handles the rest, scaling resources automatically. For single container applications, Cloud Run offers a serverless solution. Upload your container and Cloud Run deploys it as a stateless auto-scaling service. Cloud Functions are perfect for small single-purpose functions that respond to events. They add extra functionality without the complexity of larger applications. Choose Compute Engine for Windows applications, App Engine for Java or Python apps, Cloud Run for single containers, JKE for multiple containers, Anthos for hybrid environments, and Cloud Functions for event-driven tasks. Let's explore the main storage services available on Google Cloud Platform or GCP. Data can be structured like names and dates or unstructured like music and photos. Different types of data require different storage solutions. For unstructured data, Google Cloud Storage is ideal. It's fast, secure, and has almost unlimited capacity. Perfect for web pages, log files, or data lakes. Google Cloud Storage offers 4 classes: Standard for frequently accessed data, Nearline for monthly access, Codeline for quarterly access, and Archive for annual access. All provide immediate live file access. Cloud storage uses object storage, meaning no directories, just buckets. For traditional file systems with block level access, use FileStore, which supports NFS compatibility file shares. For structured data, Cloud SQL supports MySQL, PostgreSQL, and Microsoft SQL Server for higher performance. Use Cloud Spanner. For big data analytics, BigQuery is the go-to solution. In summary, choose Cloud Storage for files, FileStore for editable files, Cloud SQL for standard databases, Cloud Spanner for large workloads, and BigQuery for analytics. Google Cloud Platform offers virtual private clouds or VPCs, which allow you to organize and share resources. VPCs are logically isolated networks that can group or separate virtual machines and containers. You can also divide a VPC into subnetworks and define traffic routes. By default, all incoming traffic to a VPC is blocked and all outgoing traffic is allowed. You can create firewall rules to override this behavior, blocking outbound traffic or allowing external access to a public web server. To connect a VPC to an external network, you can use Cloud VPN for secure, encrypted traffic over the internet. For higher security and reliability, Cloud Interconnect provides a direct, dedicated connection to Google. Direct peering is another option, coordinated with your local internet service provider. Load balancers distribute network traffic among resources to prevent any single part from being overwhelmed. Cloud Armor works with load balancers to defend against application and denial of service attacks, ensuring your infrastructure remains secure. Cloud DNS manages millions of DNS records for both public and private domains. Cloud CDN accelerates web and applications content delivery using Google's globally distributed caches, enhancing performance and user experience. These are the key networking services on Google Cloud Platform designed to keep your resources connected, secure, and efficient. Google Cloud Platform or GCP offers some of the most exciting services in artificial intelligence and machine learning. Let's dive into what makes these services stand out. Artificial intelligence or AI aims to give machine human-like intelligence. Machine learning or ML is a branch of AI focused on systems that learn from data to improve over time. On the side, GCP offers the Vision API to detect objects and faces in images, the Video Intelligence API to recognize actions in videos, and Document AI to parse data in documents. Language services include the Translation API, which supports over 100 languages, and the Natural Language API, which performs sentiment analysis to classify messages as positive, negative, or neutral. Conversation services feature text to speech and speech to text APIs and Dialogflow, which generates realistic dialogue for chatbots and voice bots, perfect for customer support. Structured data services like recommendations, AI suggests products based on past purchases, while cloud talent solutions helps match job seekers with the right opportunities. For specific needs, GCP offers AutoML to train custom models without deep ML knowledge. For more advanced requirements, Vertex AI provides tools for building and deploying custom models. Security services on Google Cloud Platform or GCP help protect your data. Privacy is crucial, and security is the method to achieve it. Policies, procedures, and controls are essential to safeguard your customers and company, often shaped by compliance requirements. GCP offers several security services. Security Command Center provides a centralized control panel for discovering vulnerabilities and detecting threats. Secret Manager stores passwords, API keys, and certificates securely. Data loss prevention or DLP identifies and scrubs sensitive data such as credit card numbers from user records before responding to database queries. Operation services on GCP focuses on monitoring and maintaining your infrastructure. These tools ensure your systems run smoothly and efficiently, providing insights and automation to manage your resources effectively. The Google Cloud Operations Suite include cloud logging for centralized log management and cloud monitoring for tracking metrics like CPU utilization and network traffic. Cloud Debugger helps find software bugs, while Cloud Profiler and Cloud Trace identify latency issues. Cloud Deployment Manager automates resources provisioning. Cloud Build automates code deployment. Apigee designs secure APIs, and Cloud Composer manages workflows across clouds and data centers. Let's do a quick recap on what we have learned so far. So Google Cloud Platform offers powerful compute services. Compute Engine manages virtual machines, while Kubernetes Engine handles containers. For hybrid environments, Anthos is the go-to preferred managed serverless options. Use app engines for web apps, Cloud Run for single containers, and Cloud Functions for event-driven functions. For storage, Google Cloud has you covered. Cloud storage is the perfect for file storage. Need SQL databases? Choose Cloud SQL, Cloud Spanner, or BigQuery. For NoSQL databases, Firestore, Firebase, and Bigtable are the best options. Network is crucial. So private network clouds or VPC isolate or connect your virtual machines. Cloud VPN interconnect and peering link your company network to Google Cloud Platform. Load balancer distributes traffic, and Cloud Armor protects against internet attacks. Google Cloud excels in AI and machine learning. Use AutoML to train custom models. An AI hub for plug-in and play components. Services cover sight, language, conversation, and structured data, making it easier to integrate AI into your applications. Security and operations are vital. Security Manager stores passwords and keys securely. Cloud Debugger inspects running applications, while Cloud Profiler and Cloud Trace identify latency issues. Apigee helps build scalable, secure APIs. That's a wrap on Google Cloud Platform from compute to AI. It offers comprehensive solutions. Explore more courses on our YouTube channel and enhance your cloud skills. Thanks for watching. So let's continue our learning journey. So before you can start building on Google Cloud Platform, you need a project. Projects help organize all your resources, including users, APIs, and billing information. To create a project, log into your Google Cloud Console, click the project selector drop down and then new project. Name your project like Photoblog and let Google generate a unique project ID. Once your project is created, you can add resources. For a Photoblog, you might add a compute engine instance for WordPress, a Cloud SQL database for posts, and a cloud storage bucket for photos. Organizing resources into projects prevents confusion and enhances security. It ensures you won't mix up production and development databases and simplifies resources management. Deleting a project removes all associated resources. To delete a project, go to IAM and admin, then manage resources, select the project, click delete and confirm by entering the project ID. Projects are marked for deletion for 30 days, allowing recovery if needed. So managing user accounts and roles in Google Cloud Platform is essential for any organization. Different users have different needs and it's crucial to assign the right permission to ensure smooth operations. Each project in Google Cloud Platform has its own set of users, each with unique permissions. Some users need full access, while others only need to view or make specific changes. You can manually create user accounts or automate the process using tools like Google Cloud Directory Sync. This is especially useful for large companies with hundreds of thousands of users. So permissions are managed by assigning roles to users instead of assigning individual permissions. You group them into roles. This saves time and ensures users have the necessary permissions to perform their tasks. There are three main types of roles: basic, predefined, and custom. Basic roles offer broad permissions, predefined roles are more specific, and custom roles allow you to tailor permissions to your exact needs. So understanding and managing your permissions is crucial. Start by assigning minimal permission and adjust as needed. These ensure security and efficiency in your Google Cloud Platform projects. To access certain Google Cloud resources, you need to enable the corresponding API. Google Cloud APIs provide access to various services, but many are disabled by default. Suppose you want to interact with a user's Google Calendar, first ensure you have the correct project selected. Navigate to APIs and Services and select Dashboard. Click Enable APIs and Services. Search for Google Calendar API and click Enable. Some APIs require extra steps beyond enabling. For instance, you might need to accept terms of service or create credentials. Verify the API is enabled by checking the dashboard. When you no longer need an API, you can disable it. Select the API and click Disable API at the top of the page. Confirm it was disabled by checking the dashboard again. Only enable the APIs you need to avoid unnecessary costs. Disabling unused APIs ensures you don't accidentally use them, helping you manage your resources efficiently. Managing billing on Google Cloud Platform is crucial. You start with a $300 free trial for 90 days, but eventually you will need to pay for services. To add a new billing account, click Billing in the navigation menu, then Manage Billing Accounts. Click Create Account, assign a name, select a country, and submit. Now you have multiple billing accounts. To link a project to a new billing account, go to Account Management, select the project, then modify it to use the new billing account, confirm the changes. To disable billing for a project, click the action buttons next to the project, select Disable Billing and confirm. Remember, you're still responsible for outstanding charges. Creating a budget helps monitor spending. For the billing page, click Budgets and Alerts, then create budget, set a name, scope, and amount, define notification thresholds to receive alerts when spending exceeds certain percentages. So to generate a billing export, select Billing Export from the billing page. Choose to export all cost, confirm the project, and create a new BigQuery dataset. These help in detailed analysis. Let's review how to set up a Google Cloud Platform environment. First, create and delete projects to manage and organize your Google Cloud Platform accounts. Projects are essential for structuring your resources. Next, create user accounts and design permissions via roles. Remember the three types: basic, predefined, and custom. Basic roles like viewer and editor are simple but not secure. Predefined roles are more granular. If none fit, create custom roles. Avoid using basic roles in real environment. Then enable APIs to access various Google services like compute, storage, and networking. Control project resources by enabling or disabling the associated API. Finally, add a billing account to specify payment methods for services. Projects can share billing accounts or have a separate ones. Set spending alerts by creating a budget and analyze spending with billing exports. That's a quick review of setting up your Google Cloud Platform environment. The Google Cloud Software Development Kit, or Cloud SDK, lets you manage your Google Cloud Platform account through terminal commands. It simplifies tasks and automates repeatable process. To get started, use Cloud Shell, an online terminal in the Google Cloud Console. It comes pre-installed with Cloud SDK. Just log in, click Activate Cloud Shell, and you're ready to go. Cloud SDK includes several key commands: gcloud for common cloud tasks, gsutil for Google Storage, and BQ for BigQuery. These commands streamline your workflow significantly. gcloud is the main utility for tasks like installing components, spinning up compute engine instances, and deploying apps to App Engine. It's your go-to for most cloud operations. gsutil, or Google Storage Utility, helps manage cloud storage buckets and objects. It's essential for handling your storage needs efficiently. BQ is used for interacting with BigQuery, run queries, and manipulate datasets effortlessly with this command. Installing the Google Cloud SDK on your machine can be more convenient than using the integrated Cloud Shell. Let's walk through the process of downloading, installing, and setting up the SDK. First, visit cloud.google.com/sdk/docs/install for detailed instructions. Download the installer for your operating system, run it, and follow the prompts. Choose the installation method that best suits your needs. After installation, verify it by running gcloud help in your terminal. If you see the help screen, you're good to go. If not, revisit the installation instructions to troubleshoot. Next, run gcloud init to authorize access to your Google account. Follow the prompts, log in, and choose a default project. If you are behind a proxy, configure your proxy settings as needed. The SDK comes with default components, but you can install additional ones. Use Gcloud components list to see available components. For example, install the Google App Engine Java component with Gcloud components install app/engine/java. Google Compute Engine on Google Cloud Platform lets you design and build custom data centers in the cloud. With Compute Engine, you have almost complete control. Choose your hardware, operating system, and install any applications you need. It offers deep customization and control. There are various pre-configured machine types: general purpose for website, compute optimized for performance tasks, memory optimized for large databases, and accelerator optimized for graphic rendering and machine learning. Compute engine can save you money. You only pay for what you use, and there are discounts for sustained and committed use. Spot VMs offer short-term savings for fault-tolerant workloads. Compute Engine is a versatile and cost-effective, making it a great step for moving to the cloud. Start by creating a virtual machine today. Creating and managing virtual machines with Google Compute Engine can seem overwhelming. Let's focus on the main features to get you started quickly and efficiently. First, log into the Google Cloud Platform console. Navigate to Compute Engine by either using the navigation menu or the search bar. You will see a list of your current VMs. To create a new VM instance, click on Create Instance. You can create it from scratch, a template, or a machine engine. So we will focus on creating one from scratch. Fill out the form with details like the instance name, region, and zone. Choose your machine configuration, including the type and amount of memory. Adjust the boot disk and firewall settings as needed. Once your VM is running, Google provides a detailed logs and monitoring tools. These help you track metrics like CPU utilization and network traffic. For advanced metrics, install the Ops agent. And that's it. You have created and configured a VM instance on Google Compute Engine. With these basics, you are ready to explore more advanced features and optimize your virtual machines. Now that you know how to create a basic virtual machine, let's explore some advanced options to enhance your next step. In the networking section, you can customize your networking interfaces, choose the virtual private cloud or VPC, and a subnetwork for your instance. These allows for better network management and segmentation. You can set your internal IP address to be dynamic or static. Ephemeral IPs change when an instance is stopped or deleted. For a consistent IP, reserve a static one. The same options apply to external IP addresses, including the option to have one for added security. In the disk section, you can add and attach additional disk drives. The security section offers various options to enhance your VM security. You can also add your own secure shell or SSH keys for custom access. Under management, you can handle committed use discounts and switch to spot instances. Spot instances are cheaper but less reliable, suitable for specific workloads. They can save you money if used correctly. Finally, you can create a VM using a command line. Click to get the exact command, paste it into your terminal with the Cloud Software Development Kit or SDK installed, and replicate your settings easily. Managing a few virtual machines manually is fine, but what if you need hundreds of thousands? Let's explore how templates and machine images can simplify this process. Start by creating a VM template. Click Create Instance Template and fill out the form with your desired settings. These templates saves all your VM configuration, making it easy to replicate. Once your template is ready, use it to create new instances. Select your template, make any necessary adjustments and click create. This method ensures consistency across multiple VMs. A machine image goes a step further. It captures the entire state of a VM, including installed software. Create a machine image by selecting an existing VM and clicking create new machine image. To use a machine image, create a new instance and select create from machine image. This replicates the original VM, including all software and configurations, saving you time and effort. To delete VMs, select the instances, click more actions and choose delete. You can delete multiple instances simultaneously, streamlining your management process. Using templates and machine images makes managing VMs efficient and scalable. Before creating virtual machine instances on Google Cloud Platform, it's crucial to understand quotas. Quotas prevent excessive resources consumption and cap spending to avoid unexpected bills. Let's explore how to view and manage your quotas. First, log into your GCP console, search for quotas and click on All Quotas. This page displays all quotas for your project, including Compute Engine and API Gateway. You can filter to view specific services. To focus on a particular service, use the filter option. For example, filter by Compute Engine to see related quotas. These help you monitor your usage and identify if you're nearing any limits. If you need to exceed a quota, request a change, filter for your quota, like the number of virtual machine instances per region, select the quota to change, then click Edit Quotas. Fill out the form specifying the new limit and justification. After providing your contact details, submit the request. Google will review and respond, which might take a day or two. Now you know how to manage quotas effectively on GCP. Google Cloud Platform allows you to build virtual data centers in the cloud. One crucial component is the underlying network. Since you can't physically access Google's hardware, connectivity is essential for everything you build in Google Cloud Platform. With many customers using Google Cloud Platform, isolation is key. Company A and Company B, for example, need separate networks to avoid conflicts like IP collisions. Virtual Private Cloud solves these by allowing complete isolation while accessing the same resources. VPCs let you create private virtual networks broken down into subnetworks or subnets. You can keep things simple with one VPC or get complex with multiple VPCs and subnets. You have the option to manually manage settings or let Google handle them. One standout feature of VPC is their global nature. Servers across different regions like the United States, United Kingdom, and China can communicate within the same VPC. Alternatively, you can isolate them by creating a separate VPCs. Google VPCs balance connectivity with security. You can create open VPCs for public servers or locked down VPCs for private applications. Using Google Private Access, you can disable internet access while maintaining connectivity to other Google Cloud Platform resources. As your networking needs evolve, you might need to modify your existing virtual private cloud or VPC. Let's see how. First, go to the VPC network page. Ensure the VPC network option is selected on the left. Click the network name you wish to modify, then hit edit. To edit routes, go to the routes tab, select a region, then click on the specific route to modify it. For new routes, use route management. In the firewalls tab, you can add, delete, or edit firewall rules. click Add Firewall Rule to create a new one, or select an existing rule to modify or delete it. The Subnets tab allows you to add, edit, or delete subnets. Click on the subnet name, then choose Edit or Delete to make changes. To expand a subnet IP range, click Edit and modify the CIDR range. Remember, the new range must be a superset of the old one and cannot overlap with other subnets. For example, changing a /16 to a /15 doubles the IPs must follow CIDR rules. Proper planning is crucial to avoid issues. Expanding subnets can be done without downtime, but always ensure your addressing scheme accommodates future growth. Google creates multiple copies of everything. All data is duplicated and stored in multiple locations. Servers are replicated across multiple instances. By having redundant copies of everything, their services can survive hardware failures, software glitches, and even network outages without losing data or functionality. Having multiple copies isn't useful unless you can access one of them. Google spreads its copies across different geographic regions, so even when an entire country goes offline, Google services are still accessible to everyone else. Google has failover mechanisms to automatically handle most problems. When a server or data center becomes unavailable, traffic is instantaneously redirected to another location. This ensures uninterrupted service. Because its services are distributed, Google can easily adjust the number of instances as required. When traffic increases, servers are added to handle the additional load. When traffic decreases, servers are removed to lower costs. Cloud load balancers provide a single point of entry for resources. They intelligently distribute requests based on server health, capacity, and location. This ensures no part of your infrastructure gets overwhelmed, optimizing performance and reducing latency. Google Cloud Platform offers various load balancers tailored for specific workloads. Let's break them down using four main attributes. Access type. Load balancers can be internal or external. Internal load balancers use private IP addresses accessible only within Google Cloud. External load balancers use public IP addresses accessible from anywhere on the internet. Choose based on whether your service is internal or public facing. Next, scope. Load balancers can be regional or global. Regional load balancers distribute traffic across multiple zones, ensuring service during zonal outages. Global load balancers distribute traffic across multiple regions, providing resilience against both zonal and regional outages. Third, traffic type. Load balancers handle specific network traffic types. For web servers, use HTTP or HTTPS load balancers. For VoIP servers, use UDP load balancers. Understanding your traffic type is crucial for selecting the right load balancer. Finally, termination. Proxy load balancers terminate client connections, allowing advanced configurations like single SSL certificates. Pass-through load balancers forward packets directly, preserving client IP information. By understanding these four attributes, you can select the right Google Cloud Platform load balancers for any application. To troubleshoot load balancers, start with logging. Logs provide detailed insights into issues. Remember, logging is not enabled by default. Enable it during creation or by editing the load balancer under backend configuration. Set a sample rate to control log volume. Use Logs Explorer to filter and view specific log entries like http underscore load underscore balancer. Next, monitoring accessing. Access the monitoring dashboard from the load balancer page. Click on the load balancer, then the monitoring tab for a high level overview. For detailed insights, go to the cloud monitoring page and select Google Cloud Load Balancers. These dashboards track errors, latency, and more, helping you identify patterns and issues. Finally, create a custom dashboard. On the cloud monitoring page, click Create Dashboard. Add charts and graphs to track specific metrics like load balancer backend utilization. Customize these dashboards to suit your needs and set up alerts to notify you when metrics exceed thresholds. This combination of logging and monitoring ensures comprehensive load balancers management. Ever wondered what a VPN is? Let's break it down. A VPN, or virtual private network, creates a secure connection between private networks using the public internet. A VPN acts like a single seamless network, allowing resources in different networks to connect as if they were in the same network. It keeps your networks private and secure through encryption. Modern VPNs use encryption to securely exchange data over the public internet. This means your private networks remain inaccessible to the general public, ensuring your data stays safe. VPNs can make your device appear to be in a different country by changing your IP addresses. They also allow remote employees to securely access corporate networks and connect multiple data centers across vast instances. VPNs are cost effective and easy to set up but rely on internet connectivity. Slow or unstable internet can affect VPN performance. While encryption adds security, older methods can be vulnerable. For highly sensitive data, VPNs might not be secure enough. VPNs offer a practical solution for secure private connections. However, for higher reliability and security, consider alternatives like cloud interconnect or direct peering. Cloud VPN is a Google Cloud Platform service that links an external network with your virtual private cloud. Many companies have resources spread across on-premises, Google Cloud, and other public clouds. Cloud VPN ensures seamless communication between these environments. Classic VPN was the original offering. It uses a single interface and external IP address. While it supports static routing, a tunnel failure disrupts activities. Classic VPN is mostly deprecated as of March 31, 2022, but it's still useful for older gateways without border gateway protocol support. High availability VPN, introduced in 2019, offers multiple interfaces and IPs. If one tunnel fails, another takes over and ensures 99.99% uptime. This makes it more reliable than classic VPN. However, it only supports dynamic routing, not static. Google encourages migration to high availability VPN due to its reliability. Classic VPN is only recommended if your external network uses an old gateway that doesn't support border gateway protocol. For everyone else, high availability VPN is the better choice. Cloud VPN supports only the IPsec protocol, making it incompatible with SSL or WireGuard. It's designed for site-to-site connections, not client-to-gateway or remote access scenarios. Despite these limitations, it's excellent for hybrid and multi-cloud environments. Google Cloud DNS is a global domain name service that simplifies domain management. It allows you to map public IP addresses to public domain names and create private domain names. One standout feature is the ability to use internal DNS names instead of hard coding IP addresses. This flexibility is invaluable for managing complex infrastructure, making testing and deployment much easier across multiple environments like development, testing, staging, and production. With Google Cloud DNS, you don't need to maintain your own DNS servers or software. The service is fully managed and highly scalable, capable of handling millions of records. It offers 100% availability and low latency access from anywhere in the world. Additionally, you can generate detailed logs for monitoring and troubleshooting. Google Cloud DNS ensures high scalability and reliability. It can manage millions of records effortlessly, providing low latency and 100% availability globally. This makes it a robust choice for any business. If you already have a Google Cloud Platform account, using Google Cloud DNS is no barrier. It streamlines domain management and enhances your infrastructure flexibility and reliability. Before diving into Cloud DNS, it's crucial to understand DNS zones. A DNS zone is a container for DNS records sharing the same name suffix. These zones automatically generate essential records like NS and SOA. Cloud DNS offers two types of zones, public and private. Public zones are visible to the entire internet, while private zones are restricted to specified virtual private cloud or VPC networks. Sometimes you may need both public and private zones for the same domain. This setup, known as split horizon DNS, allows different results for the same domain name based on the source IP address. To set up split DNS, create both the public and private zone for the same domain and add the appropriate records. This way, internet users get the public IP while internal resources get the private IP. Public DNS zones can enforce DNS security extension or DNSSEC. DNSSEC authenticates responses for domain name lookups, ensuring data integrity and preventing redirection to harmful servers. DNS forwarding allows requests for certain domains to be resolved by another DNS server. DNS peering, on the other hand, forwards requests between VPCs, enabling internal to internal routing. Understanding these concepts is key to effectively managing cloud DNS. Whether it's public, private, or split zones, each has its unique advantages and use cases. To fully utilize cloud DNS, understanding DNS policies is crucial. These policies allow you to override default settings, enabling both simple and advanced configurations. On-premises DNS resolution. Handling all DNS resolutions on premises involves adding a cloud DNS policy specifying an alternative name server. This bypasses cloud DNS but increases latency and risks disruptions if the on-prem connection fails. Using Cloud DNS for all DNS resolution requires a policy for inbound query forwarding. This setup shares name resolution services across networks but also suffers from higher latency and potential disruptions if the GCP connection fails. A hybrid DNS environment combines both on-prem and cloud DNS. Set up a forwarding zone for on-prem resources and enable inbound DNS forwarding for GCP access. This approach balances flexibility and reliability, while on-prem and cloud-only strategies have drawbacks. A hybrid DNS environment offers the best of both worlds. It's a recommended practice by Google for optimal performance and minimal headache. Securing cloud resources can be challenging. As your systems grow and become more complex, the total number of potential vulnerabilities increases. Minimizing your attack surface is crucial to maintaining security. Physically securing a room with a single door is much easier than securing an entire building with many entrances. Similarly, securing a private network is easier than a public one. Assigning public IPs only when absolutely necessary. Cutting off VMs and Kubernetes clusters from the internet can limit updates and patches. Network address translation or NAT allows you to assign a single IP address to a group of computers. These enables internal network requests to reach the internet while blocking incoming requests. Setting up NAT in Google Cloud Platform is straightforward with Google Cloud NAT. It works with both Compute Engine VMs and Cloud Kubernetes Engine. Fully managed, it requires no maintenance of NAT gateways and is highly scalable and reliable. Google Cloud NAT offers flexibility with manual and auto modes. In auto mode, Cloud NAT manages everything for you. Even if a zone goes down, Cloud NAT remains available across the region, ensuring your VM stays secure and up to date. Cloud NAT allows your private virtual machines to access the internet without exposing them to public IP addresses. Let's walk through setting it up. First, ensure you have two virtual machines, a public VM with both internal and external IP addresses, and a private VM with only an internal IP address. Both should be in the same virtual private cloud or VPC but different subnets. Verify the public VM internet access using the curl method. It should return your public IP address and load websites. For the private VM, the curl command will time out, indicating no internet access. Navigate to Cloud NAT and click Get Started. Name your gateway, select your VPC network and region, and create a new router. The default settings will map all subnets to the NAT gateway and assign NAT IP addresses automatically. Click Create. Once the gateway is created, test the private VM's internet access again using curl. It should now connect successfully, showing the NAT public IP address. Explore advanced configurations like setting manual IP addresses, enabling logging, and adjusting connection settings. These options provide greater control and customization for your Cloud NAT setup. Google Kubernetes Engine (GKE) is a fully managed Kubernetes service. No need to manually install Kubernetes, it's all set up and ready to go, simplifying your operations. GKE handles most system management tasks, offering advanced features like automatic node scaling, repairing, and upgrading. This means you can focus on your applications while GKE takes care of the heavy lifting. Kubernetes is an open source container orchestration system ideal for running many containerized applications. It's especially useful for complex microservice architectures requiring hundreds of thousands of containers. Kubernetes uses a distributed system, deploying containers onto virtual machines called nodes grouped into clusters. This setup ensures high availability and easy scaling, as nodes can take over if one fails. A Kubernetes cluster has two main components, the control plane and worker nodes. The control plane orchestrates tasks and manages node health, while worker node run the containerized application. In summary, JKE simplifies Kubernetes management, allowing you to create cluster with a control plane and a worker node. This setup ensures efficient, scalable, and reliable container orchestration. Kubernetes is designed to run containerized applications. While you might think of containers, Kubernetes focuses on pods and workloads. Let's break down what these terms mean. In Kubernetes, a pod is the closest thing to a container. A pod can contain one or more containers bundled together, sharing storage and network resources. Most pods have a single container, making pod and a container almost interchangeable. However, multiple containers in a pod can work together seamlessly. You don't directly create pods in Kubernetes. Instead, you define workloads which then create the pods. The workload represents an application and sets deployment rules for pods. These includes how many pods to deploy, these hardware requirements and how they should run. Workloads ensures flexibility and scalability in your application. Initially, you will likely create workloads with a single pod and a container. But Kubernetes allows you to run pods on multiple nodes, providing redundancy and scalability. These abstraction helps Kubernetes manage complex applications efficiently. When working with Kubernetes, remember you are deploying workloads. These workloads consist of pods which contain containers. This structure offers the flexibility and scalability needed for modern applications. So let's explore how to create and manage Google Kubernetes Engine clusters. First, log into the Google Cloud Console and navigate to the Kubernetes Engine page. Click on the Create button to start a new cluster. Choose a standard cluster for more control over configurations. Name your cluster and configure the worker node, selecting machine types and the number of nodes. Node pools allow you to have different types of nodes within the same cluster. You can create multiple node pools to support various workloads. For example, one pool can have general purpose machines while another can have compute optimized machines. This flexibility helps in managing diverse workloads efficiently. Google Kubernetes Engine supports autoscaling to handle varying workloads. Vertical pod autoscaling adjusts CPU and memory resources for your pods. Horizontal pod autoscaling changes the number of pods based on resource consumption. Node autoscaling adjusts the number of nodes in your cluster, ensuring efficient resource use and cost management. To troubleshoot your Google Kubernetes engine, start by checking the logs. This is the first step to identify and fixing any issues with Kubernetes. Log into the web console and navigate to the Kubernetes engine page. Click on the cluster name and then the logs tab. Here you can filter by severity and search for the specific test strings. For more detailed information, click on the Logs Explorer link. This tool provides an expanded set of records and filters, allowing you to drill down into the details and locate error messages. Monitoring helps identify issues that aren't immediately obvious. On the clusters page, click the Operations button. This pop-up includes logs, metrics, events, and alerts. For more details, use the Cloud Monitoring dashboard. Set up alerts by clicking on Alerting. Choose the metrics to monitor and set thresholds for notifications. For example, get notified if memory usage spikes or if a pod generates many errors. By combining logs, monitoring, and alerts, you can effectively troubleshoot and maintain your GKE clusters. Developing microservices on Kubernetes involves more than just building and deploying containers. Effective communication between containers is crucial. An unreachable API is useless, and failures can cascade through dependent services. Namespaces in Kubernetes help Organize your containers. Think of them like folders in a file system, but not hierarchical. Every pod in a Kubernetes cluster is assigned to a namespace, with default being the fallback if none is specified. In smaller environments, the default namespace might suffice, but in longer setups, managing hundreds of thousands of containers in one namespace can be chaotic. Namespaces help avoid conflicts and accidental deletions by dividing the cluster into virtual clusters for different teams. Namespaces do not provide isolation. Containers in different namespaces can still communicate. Kubernetes clusters, like those in Google Kubernetes Engine, come with predefined namespaces like default, kube system, kube public, and kube node release. It's best to leave the kube namespaces alone. To demonstrate, create a JKE cluster and a couple of namespaces. Deploy a simple app to each namespace. This shows how namespaces prevent naming conflicts and help manage resources efficiently. You can also manage namespaces via the Google Cloud Console. Namespaces are essential for organizing and managing microservices on Kubernetes, especially in large environments. Imagine you have a containerized web server running in a Kubernetes cluster. Each pod gets an IP address, but these IPs change as pods are created and destroyed. These makes direct traffic routing unreliable. Kubernetes services solve these problems by defining a set of pods and setting a policy to access them. Think of services as internal load balancers, mapping a single IP address to a group of pods, ensuring reliable connectivity. There are 5 types of Kubernetes services: cluster IP, headless, node pod, load balancer, and external name. Cluster IP is the default, mapping an internal IP to pods. Load balancer uses a cloud provider's load balancer for external access. To create a load balancer service, use a command specifying the service type and namespace. This service maps to an external IP, allowing public access. Verify it works by connecting to the external IP with a curl command. Creating a cluster IP service is similar, but for internal access only. It doesn't get an external IP. To test it, connect from a pod inside the cluster using a shell command. This ensures internal connectivity is working. Kubernetes network policies are essential for controlling traffic at the IP address and port level. They help secure your cluster by simplifying what types of access are allowed for each pod or namespace. Cluster IP and load balancer services enable internal access within the cluster, while load balancer services allow external access. But what if you need more control over these connections? That's where network policies come in. By default, Kubernetes allows all traffic. However, once you create a network policy, any connection not explicitly allowed will be denied. This is crucial for securing a production environment. Network policies are defined using YAML files. You can specify policies for ingress and egress traffic. These policies are addictive, meaning they act like a whitelist, not a block list. For example, you could allow all incoming connections but deny all outgoing connections, or allow connections only for certain IPs. This flexibility helps tailor security to your specific needs. Imagine you have a web server container. You could set a policy to allow ingress on ports 80 and 443, automatically denying all other ports. This ensures only necessary traffic reaches your server. Creating a new cluster in Google Kubernetes Engine can be overwhelming. With so many options, it's crucial to understand the difference between JKE Standard and JKE Autopilot. JKE Standard offers maximum control. You decide on cluster-wide settings, node pool size, machine types, and operating systems. This hands-on approach requires you to monitor node health and compute capacity, making it ideal for those who need detailed customization. JKE Autopilot simplifies the process by pre-configuring optimized settings. It handles maintenance, auto-scaling, and repairs automatically. This approach is perfect for those who prefer hassle-free setup, leveraging Google's best practices without the need for extensive research. Autopilot can also save you money. You pay for pod instead of per node. This means you only pay for the resource you use, unlike standard clusters where you pay for provisioned nodes regardless of usage. To create a cluster, log into the Google Cloud Platform console. Choose either standard or autopilot based on your needs. Autopilot requires minimal input, while standard offers extensive customization options. Both types provide tutorials to guide you through the setup process. Autopilot suits most use cases with its ease and efficiency. Standard is best for advanced needs. Remember, you can't convert between types, so choose wisely. Experiment with both to find what works best for you. When creating a Google Kubernetes Engine cluster, you can choose between public and private. Public clusters assign nodes both private and public IP addresses, allowing direct internet access. This is useful for microservices needing external access but comes with security risks. Private cluster assign nodes only private IP addresses, isolating them from direct internet communication. These enhances security but limits connectivity. Nodes can't connect to the internet unless configured with Cloud Network Address Translation or Cloud NAT. This step is more secure but less flexible. Both public and private clusters have a public endpoint for the control plan used for cluster management. Private clusters also have a private endpoint which can be used if the public endpoint is disabled, enhancing security but limiting management options. You can restrict access to the public endpoint by configuring an authorized network. These allows only pre-approved networks to connect, balancing remote administration with security. Disabling authorized networks allow management from anywhere but increase risk. In summary, public clusters offer accessibility but less security. Private clusters provide better security by isolating nodes. You can enhance security further by disabling the public endpoint or using authorized networks. Choose based on your specific needs for connectivity and security. When creating a Google Kubernetes Engine cluster, you need to consider your availability requirements. Google offers two types of clusters, zonal and regional. Let's explore the differences. Zonal clusters have a single control plan in one zone. If that zone goes down, your cluster becomes unreachable. Nodes can be spread across multiple zones, but the control plan remains a single point of failure. Regional clusters run multiple copies of the control plane across multiple zones. This setup ensures high availability as the cluster remains operational even if one or two zones fails. Regional clusters also avoid downtime during upgrades. Regional clusters are ideal for production environments due to their resilience. Zonal clusters, while less expensive and faster to configure, are better suited for non-critical operations like development or testing. To create a regional cluster, select Autopilot in the GCP console. For a zonal cluster, choose Standard and configure your zones. Remember, the default for Standard is zonal, but you can distribute nodes across multiple zones. In Google Kubernetes Engine, traffic routing between pods can be managed using Alice APIs or Google Cloud Routes. Let's break down these two methods and their benefits. Alice IPs involve assigning multiple IP addresses to a network interface. In GKE, This means allocating a range of IPs for nodes, pods, and services. GKE then distributes these IPs as needed, making it a seamless process. Google Cloud routes, on the other hand, are custom static routes defined in a virtual private cloud or VPC. This method requires manual management of routes, similar to setting up static routes for virtual machines. Clusters using Ally's IPs are called VPC native clusters. They allocate 3 IP ranges for nodes, pods, and services. This method is best practice, offering benefits like native routability within the VPC and avoiding IP conflicts. Routes-based clusters handle IP allocation differently, requiring minimal creation of IP ranges for pods and services. This method uses the Kubernetes control plan to maintain static routes to each node. In most cases, VPC native mode is recommended for its simplicity and efficiency. Choose routes-based clusters only for specific requirements. Google Cloud Platform is a powerful tool for building almost anything, but sometimes you don't need a custom solution. Google Cloud Marketplace offers a wide array of commercial and open source software packages to meet your needs. With Google Cloud Marketplace, deploying applications is simple. No need to manually provision resources or configure software. Just pick a package, review cost, and click launch. It's that easy. To start, log into the Google Cloud Platform console, search for Marketplace, and click the link. Browse the catalog or search for a specific product. You can filter by categories to find exactly what you need. Google Cloud Marketplace offers various types of software packages: virtual machines, Kubernetes apps, software as a service, and application programming interfaces, and container images. Each type has different deployment and cost implications. Let's deploy Drupal using virtual machine. Search for Drupal, select the correct type, review details and cost, and click launch. Customize settings if needed, accept the terms and conditions, terms of services, and deploy. Once complete, manage your new VM from the Compute Engine page. Containers are fantastic. They are easy to build, deploy, and are highly portable. They start up faster and are smaller than virtual machines, but managing them can be a hassle. Manually scaling and maintaining containers is labor intensive. What happens when a container crashes or gets overwhelmed with requests? Kubernetes can help, but it adds complexity with clusters, nodes, pods, and controllers. Enter Google Cloud Run. It allows you to run containers in a serverless environment, eliminating the need to manage infrastructure. Request based auto scaling handles memory and CPU needs automatically. Start with a single instance. As demand increases, Cloud Run creates additional instances. When demand drops, it terminates those extra instances, saving you money. If a container crashes, Cloud Run seamlessly replaces it. Cloud Run supports almost everything. If you can build a container image, you can deploy it. The Google Cloud SDK can even deploy your container from source for languages like Java, Python, or Node.js. It supports hybrid and multi-cloud environments, including AWS and Azure. Google Cloud Function simplifies your cloud workflow by allowing you to trigger small bits of code based on events. These makes it easier to connect and orchestrate multiple Google Cloud services. Imagine a company wants customer to upload document images. Cloud storage stores the images, documents AI passes them, and Cloud SQL stores the data. Cloud Functions acts as the glue code to automate these workflows seamlessly. First, it requires less code, spending up development and testing. Second, it offers flexibility, enabling complex workflows with multiple entry points and exist. Third, it cost effective and scalable, as you only pay when functions run, avoiding expensive always on applications. While Cloud Run is more powerful and flexible, supporting multiple languages and better scaling, it requires more code and setup. Cloud Functions, though less flexible, are simpler and optimized for connecting cloud services like building blocks, making them ideal for straightforward event-driven tasks. Google Cloud Functions allows you to build powerful event-driven systems with minimal code, making it easier to connect to various Google Cloud products and even third-party services. Let's explore the basics of identity and access management in Google Cloud. We will also cover for practices for applying IAM to your Google Cloud platform projects. So security in the cloud means not every employee should have access. For instance, system administrator can create and delete virtual machines while developers use existing ones. Each role needs different permissions. Google Cloud Identity and Access Management, or IAM, is a managed service that enforces security for your Google Cloud Platform resources. It offers a single dashboard to view identities and their access levels across various services. Google Cloud resources are organized hierarchically. Policies applied at a higher level, like the organization level, propagate down to folders, projects, and resources. These allow for flexible company-wide protections and specific overrides. The core principle of IAM is least privilege. This means limiting permissions to the minimum necessary for each user or application. By using Cloud IAM, you ensure strong platform security, allowing only authorized users to access your resources. Let's explore how to use Cloud Identity and Access Management IAM effectively. To access the IAM dashboard, navigate to IAM and Admin from the menu or search for it. This brings you to the IAM page where you can manage project principals and roles. Principals are accounts with access to your project, while roles are groups of permissions assigned to these accounts. For example, the owner role grants full access, but not every user should have these. To assign roles, click the IAM, then add, enter the user's email and select roles like basic viewer or read-only access or app engine creator for creating applications. Save to finalize. For custom roles, go to roles and click create role, name your role, set a launch stage and add specific permissions. These allows you to tailor access precisely to your needs. Now you know how to navigate the IAM dashboard, understand principles and roles, assign roles, and create custom roles. These ensure secure and efficient management of your cloud resources. Now let's explore what a service account is and how to use them in the Google Cloud Platform project. A service account is similar to your user account, but while user accounts are for people, service accounts are for computers. For example, if software needs to write a file to cloud storage, it uses a service account. Service accounts are essential for scenarios where virtual machines or containers need to access other GCP resources. Any authentication using RSA key pairs and must have the correct permissions to perform tasks like calling an API or accessing a database. Though service accounts and user accounts seem almost identical, they differ in key ways. Service accounts do not use real email addresses or passwords. Instead, they use RSA key pairs for authentication but are managed similarly to user accounts. By creating and assigning service accounts, you can prevent unauthorized programs from accessing your GCP resources. This separation ensures that test systems cannot connect to production systems and allows you to control resource access between different teams. Managing service accounts in Google Cloud Platform or GCP is essential for controlling permissions. So let's create a service account, assign roles, and link it to your virtual machine. First, navigate to the IAM and admin page and select service accounts. Click create service account, enter a name and optionally add a description. These generates a service account ID resembling an email address. To assign roles, click create and continue. You can search for roles or scroll through the list. For instance, to allow reading from cloud storage, select storage object viewer, click done to finish. Next, create a new virtual machine in Compute Engine, name it and change the default service account to the one you just created. Confirm the VM creation and it will inherit the assigned permissions. If you need to change the service account later, stop the VM first. Edit the VM settings, select the new service account, save, and restart the VM for changes to take effect. Service accounts offer flexibility and can be used across projects. Now you know how to create, assign roles, and manage service accounts in GCP. In a production environment, numerous users, applications, and resources interact constantly. When something goes wrong, like a deleted virtual machine or denied access, detailed logs are essential to figure out the issue. Google Cloud Platform maintains audit logs that record all activity and access to your resources. These logs answer critical questions: which resource was accessed, who accessed it, what action was attempted, when did it occur. These helps in troubleshooting and maintaining security. Google Cloud's audit logs are divided into four main categories: admin activity, data access, system event, and policy denied. Each category serves a specific purpose, making it easier to track and manage different types of activities within your cloud environment. Admin activity logs record attempts to create, delete, or modify resources, like provisioning a new Cloud SQL database. Data access logs capture entries for reading or writing data to resources, such as accessing a Cloud SQL database. System event logs contain entries for Google initiated actions that modify resource configurations. Policy denied logs record every instance where access to a resource is denied, helping you identify suspicious activities or potential issues. Now let's explore how to access audit logs for your Google Cloud Platform project using the Google Cloud Operations Suite. This suite provides a centralized logging interface for all your GCP resources. To access the logging interface, use the navigation menu or search for logging. Here you can view various logs from different GCP services in one place. You can filter logs using drop-down menus, filter by resource, log name, or error severity. These filters help you quickly find the logs you need. Once you find the logs you are interested in, click the zoom icon, scroll through entries and expand sections to read detailed information. By default, logs from the last hour are shown. To change this, click edit time and set your desired time period. For example, select records from the last 7 days. From the main console, click the activity tab for a simplified summary of activity logs. Filter by country, activity type, or resource type to see specific entries like billing or configuration changes. Now you know how to find and read logs using Google Cloud Operations Suite, making troubleshooting and auditing easier. Google Cloud SQL is a powerful relational database service on Google Cloud Platform. It helps you store and organize large amounts of structured data efficiently, making it perfect for various applications. Google Cloud SQL organizes data into tables. Rows and columns make it ideal for storing customers' lists or product catalogs. It supports MySQL, PostgreSQL, and Microsoft SQL Server, offering industry standard databases without the hassle of setup. Cloud SQL is commonly used for applications running on Google Cloud services like Compute Engine, Kubernetes Engine, and Cloud Functions. It can also be accessed by external applications, whether on-premises or on other cloud providers. While Cloud SQL is a drop-in replacement for MySQL or SQL Server, Cloud Spanner is more powerful and suited for high-demand scenarios. BigQuery, on the other hand, is designed for analytics and big data, storing terabytes of information for data scientists. Cloud SQL offers automated backups, replication, and storage management. It ensures data encryption at rest and in transit, providing a secure, reliable, and highly available database solution without the headaches of manual management. Let's dive into Google Cloud SQL. Let's cover creating a server instance, importing an external database, and managing users. This is about setup, not SQL queries. First, log into your Google Cloud Platform account and search for SQL. Click to create a new instance. Choose your database engine, MySQL, PostgreSQL, or Microsoft SQL Server. Each has its own benefits and costs. Name your instance and set a password for the root user. Choose between production and developer configurations. Select your region and zone for data residency. Customize machine type, storage, and connection settings. Review everything and click Create Instance. Once your instance is ready, import data by clicking the Import button. You can use SQL or CSV files. For example, import a SQL file to create a database or populate it with records. Manage your instance from the Overview page. Edit settings, import, export data, restart, stop, or clone your instance. Use the Connect to these instance section to verify your data. Export data by clicking the Export button and choosing your format. And that's a quick guide to using Google Cloud SQL. BigQuery's storage charges are incredibly cheap. It costs 2 cents per gigabyte per month, the same as cloud storage standard. If you don't edit a table for 90 days, the price drops to 1 cent per gigabyte per month. Plus, there's no charge for reading data from BigQuery storage. The only other charge is for queries. The first terabyte per month is free. After that, it costs $6.25 per terabyte, which is about 2/3 of a cent per gigabyte. BigQuery charges query fees regardless of where the data is stored. The charge is for the processing, not for reading the data. For customers with a steady volume of queries, there's capacity-based billing. This option provides more predictable cost, but only applies to query cost, not storage. Storage charges remain separate. To see how much data will be processed by a query, you can check and query details. For example, a query processing 163 megabytes won't cost anything if you are under the free 1 terabyte limit. Even if you exceed it, the cost is less than a tenth of a cent. Google Cloud Pub/Sub is a scalable message query service designed for communication between different applications or services. It's not for emails or chats, but for tracking numerous changes and sharing updates across systems. Think of it as a tool for asynchronous messaging between applications. Pub/sub doesn't directly deliver messages from one app to another. Instead, app A posts updates which pub/sub stores. Later, app B can retrieve these updates. It functions more like a blog or forum where messages are published and anyone interested can read them later. Pub/sub supports various communication models: one-to-many, many-to-one, many-to-many, and one-to-one. This flexibility allows it to cater to different messaging needs. For instance, one sender can reach multiple recipients, or multiple senders can communicate with a single receipt. Google Cloud Pub/sub can handle immense data volumes, sending over 5 million messages per second, equivalent to over 1 terabyte of data. It's a global service ensuring messages are delivered with consistent latency regardless of location without manual replication. This makes it highly scalable and reliable for modern applications. Cloud Pub/sub supports the publisher subscriber model. It involves publishing messages to a topic, subscribing to a topic, and receiving messages from a topic. A message is data exchanged between services, stored as a text or byte string. Publishers add messages to topics, which acts as a queues for related messages. Topics can have one or multiple publishers. Subscribers are services that wish to receive messages from topics. Each subscriber needs a separate subscription for each topic. Subscriptions ensure that messages are delivered to the right subscriber. Subscribers can receive messages by pulling them manually or having them pushed to an endpoint. Pull subscriptions allow control over when messages are received, while push subscription notify subscribers as messages arrive. Subscribers must acknowledge or ACK each message to confirm receipt. Acknowledged messages are resent until acknowledged, ensuring no messages are lost even if a subscriber crashes. Cloud Pub/sub offers flexibility and resiliency in message delivery, making it easier to manage changes and ensure reliable communication between services. Cloud Pub/sub offers two services, Pub/sub and a Pub/sub Lite. Pub/sub is a more powerful option, providing high reliability, global routing, and automatic capacity scaling. It supports per message parallelism and replicates messages across multiple zones, making it the default choice for most users. Pub/sub Lite is a more affordable alternative with lower availability and durability. It requires manual resource management and is limited to a single zone. Despite these limitations, it can be significantly cheaper, making it suitable for cost-sensitive applications. Pub/sub automatically scales capacity and offers unlimited message storage with a 7-day retention limit. In contrast, Pub/sub Lite requires manual capacity management, offers over 10 terabytes per topic, and allows unlimited message retention. Pub/sub routes messages globally, while Pub/sub Lite is restricted to a single zone. Pub/sub operates on a pay for what you use model, ensuring you only pay for the resources you consume, and the Lite version, however, follows a pay for what you provision model, which can lead to higher cost if you over provision capacity. Choose based on your specific needs and budget. Cloud Pub/sub is perfect for real-time event processing. It can create an enterprise-wide data sharing bus, tracking business events, user interactions, and system failures as they happen. These allows for immediate responses to critical events. Pub/sub excels in parallel processing. Imagine a website like YouTube. When a user uploads a video, multiple tasks can run simultaneously. One process re-encodes the video, other scans for copyright issues, and the third generates closed captions. All these tasks can be auto-scaled using microservices. Pub/sub is also great for tracking database changes. It notifies interested services when records are added, edited, or deleted. These can synchronize multiple databases, creating incremental backups or log changes for big data analysis. Internet of Things devices generate massive amounts of data. Pub/sub captures, stores, and filters these data, preventing services from being overwhelmed by unnecessary notifications. These ensures efficient data management and processing. Managing data growth is crucial to avoid runaway cost. Even with Google Cloud's vast storage, object lifecycle management helps control these costs effectively. You can manage cost by deleting old objects or moving them to cheaper storage classes like nearline or cold line storage. These can be done through the Cloud Storage Console, the G Cloud Storage command, or Google API client libraries. First, create a lifecycle configuration file with rules. For example, delete any live object older than 365 days. Test these rules on non-production data to avoid accidental data loss. If versioning is enabled, old objects become non-current instead of being deleted. Use the command gcloud storage bucket describe to check if versioning is enabled. Enable it with gcloud storage buckets update. Instead of deleting, you can move objects older than 1 year to nearline storage. Objects in nearline storage older than 3 years can be moved to cold line storage. Apply these rules using gcloud storage buckets update. Monitor lifecycle policies through expiration time, metadata, and usage logs. Set up a logging bucket and enable logging with gcloud storage buckets update. Always test lifecycle rules on non-production data first. Data is the lifeblood of any business. Marketing data reveals trends, customer data improves offerings, and operational data optimizes processes. But using this data effectively is often challenging. Data can be stored in various formats and locations, from SQL databases to text files. Consolidating and standardizing this data is crucial but complex. This is where data pipelines come in. A data pipeline is an automated workflow that moves and reformats data. It copies data from one location, transforms it, and writes the results to another. Pipelines can consolidate multiple sources into a single data lake or warehouse. Data pipelines have three main phases: reading data from a source, transforming it, and writing it to a sink. The transformation phase can involve reformatting, filtering, or joining datasets. Each transformation generates a new, immutable dataset. Data pipelines break down data silos and handle repetitive tasks like extraction, cleaning, and formatting. They ensure data remains clean, consistent, and ready for analysis, making information more accessible and useful. Building and managing data pipelines can be challenging. Google Cloud Dataflow simplifies this process by offering a managed service for executing and maintaining data pipelines on Google Cloud Platform. Data flow is serverless, automatically allocating and scaling resources. It handles workloads for any size, ensuring performance remains unaffected even during sudden spikes in data value. Data flow manages job scheduling, fault tolerance, and monitoring. It built-in tools help visualize pipeline execution, identify errors, and optimize performance, allowing you to focus on developing pipeline logic. Unlike many services, Dataflow supports both batch and streaming jobs with a unified programming model, offering flexibility and simplifying workflows. Batch pipelines process large, finite data sets at specific times, while streaming pipeline handles real-time unlimited data. Dataflow uses windows and triggers to manage and process streaming data efficiently. To build pipelines, use Apache Beam, an open source framework supporting multiple languages. Beam acts as a blueprint and Dataflow executes the pipeline, managing the environment and monitoring results. After setting up your infrastructure on Google Cloud Platform, the next step is to establish a monitoring system to alert you to major issues. Use Cloud Operations, formerly known as Stackdriver, for monitoring and logging. Access it by selecting Monitoring from the menu or typing Monitoring in the search bar. You can install an agent on a virtual machine for more detailed information, but it's not necessary to start. To monitor a web server, create an uptime check. Leave the protocol as HTTP and resource type as URL. Enter the IP address of your web server instance. Set the check frequency to 1 minute and response timeout to 10 seconds. Enable logging for failures. Set up an alert for uptime check failures. Name the alert and specify the failure duration before triggering an alert. Choose how to receive notifications such as email. Add your email address and name, then refresh and select your email for notification. Title the uptime check and test it. If the web server is down, you will receive an email notification. View uptime data and latency graphs to monitor server performance. Create custom dashboards for additional metrics like CPU and memory utilization by installing the Ops agent. Real-time monitoring is great, but sometimes you need to look back at past events. That's where Google Cloud audit logs come in handy. They track who did what, where, and when. There are 4 types of audit logs. Admin activity logs track actions that modify resources like shutting down virtual machines. System events logs monitor Google's cloud's action, such as maintenance. Data access logs track data requests, including read requests on configurations. Policy denied logs record access denials due to security policy violations. To find when a virtual machine was shut down, search for logging in the console. Filter by the specific virtual machine instance and select the activity log in the Cloud Audit Log section. Search for entries containing the word stop to see shutdown events. For in-depth analysis, export logs to BigQuery. Create a sink in the More Actions menu, name it, and choose BigQuery as the sink service. Create a dataset if needed. Once set up, generate log entries and check BigQuery for the data. Use SQL statements to search through the logs efficiently. Let's explore how to get error information from your applications using Google Cloud's error reporting service. We will use Google's Hello World application in App Engine to demonstrate. First, open Cloud Shell, which has all necessary packages pre-installed. Clone the Hello World application using the git clone command and navigate to the app directory. Run the local development server to ensure the app works. Click the web preview icon and select preview on port 8080. You should see a hello world message. Stop the server and deploy the app to App Engine using the gcloud app deploy command. To generate an error, edit the code to introduce a problem such as dividing by 0. Save the file and redeploy the application with gcloud app deploy. These will trigger an exception. Check the Google Cloud Console for errors. Click on the error to see details, including a stack trace. To get notification for errors, go to the error reporting page and click Configure Notifications. Select or create a notification channel. That's it for error reporting. Is your application running but performing too slow? Cloud Trace and Cloud Profiler can help. These tools from Google Cloud provide insights into latency and resource usage, optimizing your app's performance. Cloud Trace shows the latency of each application request, helping you identify slow requests. The trace list displays all traces over a specific period, visualized in an interactive graph. Clicking on a trace dot reveals a waterfall view, showing the total end-to-end time and the time taken by each call. These helps pinpoint which calls are slowing down your application. Analysis reports in CloudTrace show latency distribution and identity performance bottlenecks. You need at least 100 traces to generate a report, providing a comprehensive view of your app's performance. Cloud Profiler analyzes which parts of your code use the most CPU and memory. Even if your app runs in App Engine, you need to add instrumentation code to use Cloud Profiler. In Cloud Profiler, a flame graph shows CPU time taken by each function. For example, in the Shakes app sample, one function took 58% of CPU time, highlighting areas for optimization. Now let's cover 206 real exam question answers for Google Cloud Certified Associate Cloud Engineer exam. These question answers PDF is also available to download from shapingpixel.com website. The full link will be in the description. Each question in this video will be played for 1 minute without sound. If you think it's too slow or fast, use the YouTube video settings to slow down or fast forward the video. So let's jump on to the questions. Thank you for watching this video. And these question answers PDF is available from shapingpixel.com website. The full link will be in the description.